everyone, I'm teacher Ninya and today we are on an adventure to explore the water cycle, a truly amazing process that shapes our world and our weather. Think of it as a giant, a never-ending recycling program for water, constantly moving and changing form. Understanding this cycle is a key to understand atmospheric humidity, which is our main lesson all about. This is how much water vapor is floating around the air. So let's start with water cycle's journey. Imagine a sunny day at the beach. The sun's heat is directly warming the sea water. Nearby in the beach, you see a puddle slowly disappearing. What happened to the water in the puddle? The sun's heat is turning the liquid water in the puddle and also in the vast oceans into a visible gas called water vapor. So this process is what we call evaporation. It's like the water molecules are getting so much energy from the sun that they bounce around so fast they break free and float in the air. This process is happening everywhere, in the ocean, lakes, river, or even from our skin. Plants also contribute through transpiration. It releases water vapor through their leaves like a tiny natural humidifier. The sun's energy is the driving force behind the phase change, whether it's a small puddle or a massive expanse of the oceans. As water vapor rises, it encounters cooler air. Think about what happens when you breathe out on a cold day. You see your breath. That process is called condensation. The water vapor, now losing energy in a cooler air, turns back into tiny liquid water droplets. These droplets are too small to see individually, but they clump together around a tiny particles in the air, just like dust and pollens, to form a clouds. It's like a massive invisible water party happening high above. Now is the clouds. It's like a giant sponge holding lots of water droplets. Eventually, they get so full that they can't hold anymore. And that is when we get precipitation. This can be rain if it is a liquid form, a snow if it is ice crystal, a sleet if it is a frozen raindrops, a hail if it is ice ball formed in a thunderstorm. It's like the clouds are doing a big water dump, sending the water back down to the earth. But the question now, where does precipitation go? Some of them soak in the ground, becoming groundwater, which is a vital source of drinking for us human beings, also for plants and animals. Some flows over the land as runoff, creating streams and rivers that eventually flows in the lake and back to the ocean. Some even freeze from glaciers and snowpacks. It's like the water is finding its home, resting, and preparing for the next stage of its journey. So the water cycle is a continuous loop of evaporation, condensation, precipitation, and collection. It's a vital process that provides us with fresh water, shape our weather, and support all life on Earth. It's a truly remarkable and natural system. Now that we understand water cycle, let's connect it with atmospheric humidity. Remember the water vapor produced during evaporation? The water vapor is what makes the air humid. The amount of water vapor present in the air directly determines the humidity level. More water vapor means higher humidity. Humidity isn't just a number. It's a crucial factor influencing our weather and comfort. It plays a significant role in cloud formation as water vapor condenses to form droplets around microscopic particles in the air. These droplets, when numerous enough, create clouds, leading to precipitation. Furthermore, Humidity affects how we experience temperature. High humidity level can make us feel significantly hotter and stickier because water vapor in the air hinders the evaporation of our sweat from our skin, reducing the body's natural cooling mechanism. Therefore, humidity is a key element in understanding weather patterns and how we perceive the temperature around us. So, we've talked about humidity and how much water vapor is in the air. Now, let's talk about something that affects both humidity and how water behaves. Altitude. Imagine you're boiling a water to make a pasta. At sea level, the air pressure is high. It's like a heavy blanket pressing down on everything. Water needs to reach a specific temperature, which is 112 Fahrenheit or 100 degrees Celsius, to overcome this pressure and boils. But as you go higher up the mountain, the air pressure gets thinner and the air pressure decreases. It's like the blanket is lighter. With less pressure pushing down, water molecules need less energy to escape and turn into steam. This means water boils slower at a lower temperature and at a high altitude than vice versa. This is why it takes longer to cook pasta on a mountain. We've talked about humidity, but let's get more specific with relative humidity. It's not just about the amount of water vapor in the air, but how much the air could hold at a given temperature. Think of a sponge. A small sponge can only hold a little water, while a big sponge can hold a lot. Warm air is like a big sponge. It can hold more water vapor than a cold air, which is the small sponge. Relative humidity is the percentage of how full the sponge is. 50% relative humidity means the air is holding half of the water vapor at a given temperature. Let's compare high and low humidity. High humidity is nearly a full sponge. The air is almost saturated with the water vapor. This makes us feel heavy, sticky, muggy, especially when it's warm. Your sweat has trouble evaporating, so you feel hotter and less comfortable. Less humidity is most like the empty sponge. The air is dry and can hold much more water vapor. It can make your skin feel dry, your lips chapped, and your nose feel stuffy. We can control humidity indoors. Most people feel most comfortable indoors with relative humidity between 30 to 50%. High humidity or above 50 promotes mold, mildew growth, potentially causing allergies and respiratory problems. Low humidity or below 30 dry out skin, eyes, and nose, leading to discomfort and increased susceptibility to colds. Humidifier adds moisture while the humidifier removes it, helping maintain a healthy indoor environment. High humidity interferes with your body naturally cooling system, which is the sweat, making you feel hotter and stickier because sweat evaporates more slowly. Low humidity also causes problems by drying out the skin and mucous membranes, increasing illnesses and risk. Humidity is a big deal. It affects everything from how we feel to the weather we experience. Understanding humidity helps us create comfortable indoor environment, predicts weather patterns, and even protects our health. From the way the water boils at different altitude to the way humidity makes us feel, it's fascinating and important part of our world.
Good morning, everyone. Today I will be discussing computing relative humidity, dew point, and air density. But before that, I have here a question. Have you ever noticed how some days feel sticky and others dry? Or wondered why humid air sometimes seems heavier? Before that, let's know what is relative humidity. Relative humidity is the amount of moisture in the air compared to how much moisture the air can hold at a given temperature. It is expressed as a percentage. The relative humidity tells us how much moisture is in the air relative to its capacity. When the air is fully saturated, the relative humidity is 100%. Now we calculate relative humidity using this formula. E, which is our actual vapor pressure, and the E sub S, which is our saturation vapor pressure. Here, the relative humidity is equal to our actual vapor pressure over saturation vapor pressure times 100. We calculate the relative humidity. Next, let's apply this formula. Suppose the air temperature is 27 degrees Celsius, and from our table, the saturation vapor pressure at this temperature is 35 millibar. If the actual vapor pressure is 21 millibar, then the relative humidity is 60%. Now, here is a table showing how saturation vapor pressure changes temperature. High temperature allows moisture in the air. Now, let's proceed to what is dew point. Dew point is the temperature at which air becomes saturated and condensation begins. Dew point is the temperature at which air can no longer hold moisture, leading to condensation. If the dew point is high, it means the air contains a lot of moisture. If we know the actual vapor pressure, we can use to find dew point. For example, if our actual vapor pressure is 21 millibar, then our dew point is 18 degrees Celsius. Now, humidity affects how we perceive temperature. The heat index, also known as the apparent temperature, combines air temperature and relative humidity to determine how hot it feels. As we can see in figure 4.21, air temperature is 96 degrees Fahrenheit with a relative humidity of 55%, produces a heat index of 112 degrees Fahrenheit, meaning it feels much hotter than the actual temperature. This is why high humidity can increase the risk of exhaustion and heat stroke, making it dangerous for people exposed to extreme heat. Now let's proceed. Which is heavier, the humid air or dry air? Many people assume humid air is heavier than dry air, but in reality, it is lighter. This is because water vapor molecules have lower molecular weight than nitrogen and oxygen, which make up most of dry air. Since humid air is less dense, it tends to rise, influencing weather patterns and cloud formation. Now, this table compares the molecular weight of gases in the air. Dry air, which consists mostly oxygen and nitrogen, has a molecular weight of 29. Water vapor with a molecular weight of 18 is much lighter, making humid air less dense. Humidity is measured using different instruments. One common tool is the psychrometer, which consists of 2 thermometers, one dry and one wet bulb. By comparing this, we can determine the relative humidity of the air. Now let's have the sling psychrometer. Sling psychrometer are used to measure the air and wet bulb temperature to determine the relative humidity and dew point temperature. This is the sling psychrometer. This is a common device used to measure humidity. It has 2 thermometers, one is dry and one is wet. The difference in reading helps us determine relative humidity. Another instrument is the hair hygrometer, which uses strands of hair that expand or contract depending on the humidity level. These measurements help meteorologists predict weather conditions and climate changes. Now for our summarization. In summary, we learned that relative humidity measures how much moisture in the air compared to its maximum capacity. Dew point is the temperature at which air becomes saturated and begins. The heat index explains humid why humid weather feels hotter than dry weather. Humidity measurement tools such as the psychrometer or the sling psychrometer and the hygrometer help us track atmospheric moisture. Lastly, humid air is lighter than dry air, which affects weather patterns. Thank you for your attention. I hope this presentation helped you understand the importance of humidity in our daily lives.